Hello everyone, Nishant here from Learn QA Skill. In today's video, we are going to learn about levels of testing. So what are the different levels of testing available in the testing? So in that, we will be learning about unit testing and second is the integration testing. So these two levels of testing we are going to learn in today's video. So in a testing, there are four levels of testing. First is a unit testing, second is a integration testing, third is a system testing, and fourth and last one is a user acceptance testing. So first we will discuss about unit testing. So let me tell you first what is the unit. Unit is the smallest component of anything. If you talk in terms of software, so software is a collection of programs. So here we can call one single program is a one unit of a software, or in the other terms we can say that the software is made up of multiple modules and submodules. So here we can consider one single module is a one unit of a software. So when we conduct the testing on this one single program or one single module, that we call as a unit testing. And the unit testing is a white box testing techniques, because to conduct the white box testing we should know the programming knowledge, and the developer is writing the actual program for the software application. So they having the programming knowledge, they are developing the application, so they themselves conducting the unit testing. So that is why this unit testing is a white box testing technique, and the unit testing is conducted by the developers. There are different techniques used by the developer to complete the unit testing. So here we have statement coverage, branch coverage, condition coverage and path coverage. So the statement coverage means testing the each line in the program or each statement in the program at least once, that is called statement coverage. Next is the branch coverage. Branch coverage means verify all the branching statements in the program, that is called branch coverage. Third one is a condition coverage. Condition coverage means testing all the conditions in the program, that is called conditional coverage. Fourth one is a path coverage. Path coverage means verify the flow of execution of program, that is called path coverage. So here I have taken one example which is written in Java, which is to print the greater number out of given two numbers. Okay, and the same program I have converted into the flowchart, so you can understand better. So the program will start from here. It will take a two input, then it will check the condition which number is greater. Based on the condition, it will print either A is greater or the B is greater. So here we have taken the value of A is a 50 and the value of B is a 20. So A is greater than B. So this condition will check, and after this condition, the A is the greater value here 50. So this will print A is a greater, and then program will stop. So this is the flow chart I have converted from this program. So in this flow chart, the boxes you can see that call as a node. So this is so testing all these nodes at least once, all these statements at once, that is called statement coverage. Then these lines you can see in the flow chart, this we call as the branches. Okay, so checking all these branches is called branch coverage. So in this flow chart, we have taken one condition, A is greater than B. So like this, there are n number of conditions we used in the program. So checking all those conditions, that is called condition coverage. And last one is a path coverage. So path means verify the flow of execution of program. So this flow chart has a two paths. So it's starting from here, then it will take two input and it will verify the condition. If A is a greater, it will print the A is greater and then stop. If here B is a greater, then print B is a greater and then will stop. So you can see that here are two paths which is starting from here, and this one is a one path if A is a greater, and starting from here, and this one is another path if B is a greater. So checking this flow of execution of program is a path coverage. Next is the integration testing. So integration testing is conducted by integrating two or more than two components in the same application or a different application. So integration testing is conducted when we are integrating the more than 2 modules, either in the same application or in the different application. So we can integrate the 2 modules whenever there is a dependency between the modules. Then only we can integrate the 2 modules together. And integration testing focuses on checking the data communication between the multiple modules. So data communication means if there is a 2 modules, so if we give input to the some module, it will produce some output. So that output is work as an input for the second module. So there is some dependency between these 2 modules. Then we integrate these modules and then we test the data communication between these connected modules. There are 4 types of integration testing: top-down integration approach, then bottom-up integration approach, then hybrid, sandwich or mixed. These all are same. Then last one is a big bang approach. So one by one we will discuss each in detail. Next is a top-down integration approach. So in the top-down integration approach, we are incrementally adding the modules and testing the data flow between the modules and ensure the module is added is the child of previous module. So whenever we develop a software, incrementally we are adding the modules. Okay, so first we develop one module, then we develop a second module, and the second module is integrated with the first module. Then integration testing is conducted. Then again we develop another module, and that module is integrated with the existing module. That is called incrementally we are adding the modules one by one in the software application. And then we are conducting the testing. That is called integration testing. So in top-down integration approach, first we develop the parent module or main module, then we develop the child module or sub-module. Then we integrate these 2 modules and then test the data flow between these modules. And in the top-down integration approach, the testing is conducted from parent module to child module. So as you can see in the screen, so first module 1 is developed. Then module 2 and module 3 is developed. But this module 2 and module 3 is the child of module 1. And this child module is integrated with the parent module. Then the testing is conducted to check the data flow between these modules. Then again we develop a few modules and we integrate with the module 2 and module 3. So the new modules which we have developed, this should be child of the existing modules. Then we integrate this module 4, 5, 6 and 7 with the existing parent module. Then we conduct the testing to check the data flow between all the modules. And once all the modules are integrated, then the testing is conducted in the top-down approach from the main module to sub-modules. Next is a bottom-up integration approach. So it is exactly the opposite of top-down integration approach. In here as well, we are incrementally adding the modules and testing the data flow between the modules and ensure that the modules are added are the parent of previous module. So in bottom-up integration approach, first we develop the child modules and then we develop the parent modules. Then this child module is integrated with the parent module. Then the testing is conducted to check the data flow or communication between these integrated modules. In bottom-up integration approach, first the child modules are tested or sub-modules are tested, then the parent modules or main modules are tested. So as you can see in the screen, so first this module 1, 2, 3, 4 are developed and then the module 5 and module 6 are developed, but those are the childs of module 5 and module 6. Then again we develop the module 7 and this module 7 is work as a parent for all these modules, and the testing is conducted from bottom to top, from sub modules to main modules, to check the data flow or communication between all these modules. Next is a stub and drivers. So the stub is a temporary component which is used at the place of submodule in a top-down integration approach. Suppose there are 2 modules in the application and those 2 modules are dependent on each other. So first is a parent module and one is a child module. So parent module is developed but child module is not ready yet and we have to conduct the integration testing. So at the place of child module we use some temporary component. So that is called stub, and stub simulate the called modules or called component. So stub is used as a temporary component at the place of submodules to generate some dummy response. Next one is a driver. Driver is also a temporary component which is used as a substitute for main module in bottom-up integration approach. So this is exactly opposite of stub. So stub we use in the top-down integration approach as a substitute for submodules, and the driver is used in the bottom-up integration approach as a substitute for parent module or main module. And driver simulate the calling modules or calling component. So driver is used at the place of parent module to generate some dummy response or fake response. So we can continue with our integration testing. So as you can see in the screen, so this is the module to be tested, and if the parent or main module is not ready, at the place of main module we place some dummy component that is called driver, and from this driver we can call the module to be tested. So this is the calling component. And in the same examples you can see the stub. So these are the child modules. The module to be tested is the parent of these stubs. So these stubs are called by this module to be tested. So the stubs are calling component. Next is a hybrid and Big Bang integration approach. Hybrid approach is a combination of top-down and bottom-up integration approach. Next is a Big Bang approach. So in the Big Bang approach, adding all the modules in a one go and test the data flow between all the modules. So what we do in the Big Bang approach, suppose in the application there are 10 to 15 modules are there. So we will wait for all the modules to be developed, then we will integrate all the modules in a one go, and then we will conduct the integration testing to check the data flow or communication between all those modules. So this is Big Bang approach. There are two drawbacks of this approach. So first drawback is we might miss the data flow between some of the modules because all the modules is integrated in a one go. So we may miss some data flow between some of the modules. And second drawback is if you find any defect, we can't understand or we can't find the exact root cause of that defect. The defect belongs to which module. Because of these two drawbacks, Big Bang approach is not recommended. Thanks for watching the video.